All right, so I want to talk about these three aromatic compounds, and I want to talk about how we rank these in terms of acidity, okay? All right, here's where we're at here, and this really is a resonance problem when you think about it, but let's number these, and we're just going to say this is 1, this is 2, or you know what, because we are going to be ranking these, A, B, and C. Okay. Everything on these molecules are the same, except for when we look at these functional groups, right? We have this alcohol here, we have this carboxyl here, and we have this, ethyl alcohol here. I think, or that's like a methylene in alcohol. I don't know. Doesn't matter. Because this is what we're going to do. We're going to look at A. And we're going to say, okay, well, we do care what you're attached to a little bit. Everything is kind of attached to the same thing. All right, so we're just going to start. We'll say, okay, you were here, you were here. You have an O. And we're looking at these as acids. So what we're looking at is we're going to be deprotonating these, okay? Now let's look at B. And I'm going to draw it out, because if you draw this out, you're going to have a better time. And it's an OH. And I'm also going to include the lone pairs let me do that here too. So that's A, this is B, CH2, 6143210, H, okay. And then we're going to go to C. C. Now you kind of have to remember what this carboxyl group looks like, because you are going to have a double bond with an oxygen. And it's going to look like this. Okay, so going from here, all right, so now what we can do, now that we have these all drawn out, is we can deprotonate. All right. So we're going to lose a hydrogen, well, a proton. And what is this going to become? Well, what this will become on this side is we're really just going to be left with our oxygens on the very end. So this oxygen, so we're losing a positive charge. That proton, the electrons are still there from this hydrogen. They're just going to kind of collapse back into this halogen here. 6, 5, 4, 3, 2, 1, 0. Negative 1. Okay. And as you can see, as we do this, well, we're going to be left with the same exact thing. So you might be asking, well, what the heck do we do then, right? This is going to be a negative 1. And this will also be an O minus. 6, 5, 4, 3, 2, 1, 0, negative 1. Okay, so we are looking at the same thing here for each one, which means we need to go back a step further and we need to see what's happening. Now, before we do that, we have a negative charge. If we have a charge on something, a charged molecule is going to be fairly likely, this O minus is going to be fairly likely to pick up an H plus just out and about and turn itself right back into its conjugate acid, right? Over here, we have our acids, at least that we're looking at. And then over here is our conjugate base for each of these. Okay? And if we have something that's charged, and I always just remember that OH minus is like, you know, OH minus is like the base of all bases, and H plus, a proton, is like the acid of all acids. That's kind of what your hint is sometimes. But anyway, we have this negative charge, very likely to pick up a proton. So what does that mean? It's charged. It means it has some fight. If it's charged, I kind of think of it like lightning or like a racehorse or something. It's got some fight in it, which makes it stronger. Which means if this is a horse, I'm not going to draw it. If you're a horse, you're coming out of the stable. You're unstable. All right? You're unstable. You're going to be a strong base. If you don't have a charge, no charge, if your horse can't charge, you have no fight. Your horse is literally in the stable. You are stable, therefore you are weak. Because you have no charge, you have no fight, and these are the characteristics of a weak base. So we have something that's charged here. So if this is charged, remember that was no charge, this is charged. All right, these are going to be relatively strong bases over here. And a strong base, which can fight back, which has a fight and can fight back, well, if it can fight back, it's going to have a weak acid on the other side. But if you have a weak base and your horse is in the stable and you're in, you're locked in this stable, you got no fight, you got no charge. Well, the thing on the other side is what's keeping you in the stable, It's a strong acid. It is keeping you stable. It is keeping you in that stable. You are not going to pick up a proton. There is no way in hell you're coming back. A weak acid with a strong base, you are wild, you are crazy, you are unstable, you are charged, you got fight in you. You are coming out of that stable, you are unstable, okay? So, because these are all charged, we can say that these are strong bases, but they're all the same. So now we look into resonance. If we go back and look at, well, we're at this part in all of these. Well, what comes next? Okay. So what we're going to look at here, and remember, resonance really has to happen in proximity to a double bond. So these electrons on A can hop down, create a double bond, and force this double bond to keep moving, okay? So we have some resonance going on up here, okay? This one, this lone pair, well, it's not going to hop here. First of all, if it hops here, and then we have a fifth bond with carbon, well, that's not going to work. There's really no place for these to go. There's no resonance in this one, okay? But look at this one down here. This lone pair, it can hop here, and there's a double bond right there, and that double bond can then become a lone pair up here. And then you can also keep going at the same time. This double bond is also, could hop here and so on. So you kind of have two levels. You kind of have more opportunity, at least that's the way I looked at it. You have more opportunity for resonance here. Okay. It also might have something to do with hybridization, potentially. I'm not sure. But greatly enhanced by electron withdrawing inductive effect, the stability of the conjugate base. So that could also be in line here. Anyway, okay, so because there's no resonance happening here, and when I think about resonance, I think about basically a barrier, right? Resonance, you see in like these double bonds. If you're charged and you're coming and you're ready to go back to the other side, pick up that proton, go get that acid that has harmed you, and you hit resonance, that's going to prevent you from doing this. So whatever level of stability that you have, if you're unstable, well, this is going to stabilize you a little bit. If you're a strong base, this is going to make you a bit of a weaker base. So, because there's no barriers here, this one is the strongest base. And therefore, it's the weakest acid. So our middle one here is going to be our weakest acid. Okay. So now we're just looking at A and C. Now, I already think that because C has more roadblocks, it's going to be stable even more. So it's unstable, it's going to be a weaker base because it has more barriers to walk through. I think this is going to be a weaker base, or the weakest base. And therefore, it's going to be the strongest acid. Okay? So C, this last one, is going to be our strongest. I think there's one other thing that we can look at here, and that's this oxygen. Oxygen is electronegative, right? It has an electronegative value of 3.5. So in addition to the more resonance options here, the oxygen is going to have what's called electron withdrawal. So it's going to pull electrons towards it, and that increases the strength of the acid and makes the base even weaker also. But if this pulls electrons towards it, you would think that something negative, well, yeah, I guess this is missing an electron, and this is pulling electrons. So I guess that makes sense. Electronegativity, you're pulling electrons. You're pulling negative. Yeah, if you're pulling negative, that probably means you're pushing positive more. And if you're pushing more positive and you're pushing more protons, that's going to make you a stronger acid, which is why C is the strongest acid, and this one is in the middle. And on mastering, that's correct. It goes 2, which is B, followed by 1, followed by 3, which is C, which is the strongest.